and welcome back to my YouTube channel. Today we are diving into the world of hydrography and learning how to process hydrographic data using the Hydromagic software. This tutorial will take you through all the essential steps. So let's get started. We start this video by launching the Hydromagic software and loading the raw data.
To import, you just right click on the raw data, the folders over there, import data wizard. You have your Hydromagic raw data files. That's where you get your files. Then you browse to the location of the raw data. Then you select. So you just browse to the folder, and then the files will appear over here. And you select all the files that you want to work with. And then you go to next, and then it imports everything over here. So this is the one from 17th, and we have that from yesterday over here. So during the processing, draw boundary. So the two options you have one that you leave out the levels, and then you use the height that the GPS will be giving you. But with that one, when we check, the GPS is giving us ellipsoidal height without the autometric height, so we can't use that one. So we'll have to take the manual leveling. The manual levels on site before the start of the work and then after. And we'll create a file. We'll create a file in the Hydromagic for you to know which height it started with and then which height it is ending with, before it can give you your reduced level. You have to get that's from the GPS. This GPS you have is not broadcasting the autometric height, only ellipsoidal height. So if you have a GPS that is broadcasting autometric height, then you can use the first approach. Yeah. So I'll show you where you will see the data to know whether it is broadcasting ellipsoidal height or the autometric height. Once you are done with the boundary, you apply your level of 183.01. Okay. So you have our boundary around the data we picked yesterday. Okay, so here we have our raw data. You analyze the raw data. You have here depth. We are using just right click on the raw data, manage files. There it's open. Right. Yeah. So you have the raw data over here. You right click, analyze file. So you have your depth. There is the low frequency and the high frequency. We are using a symmetric frequency, so only the high that we are getting. and then this is the next data. Also, you check the time you are starting. That's what you'll be using to create the level file that you'll be applying for you to get your level. So we started at 256. Okay, so the next data, we have our eastings, northerns. This is the ellipsoid. As you can see, you have mean sea level right here, but it's the same data. It's just the ellipsoid that it is. Okay, as you can see here too, it's 210. It's 210, but what we picked on site is 183. Around that. Sure. Yeah. Next data, you have longitude, latitude. Yeah. So that's where you see which height it is broadcasting. So if you check on this page and then you don't see differences between the ellipsoid and the mean sea level, then you know your GPS is not broadcasting the autometric height. So we check the time we started. We have 1 year. So they are all 17. I think one is 15. If you take the 15, about 3. We pick the same data. We've already picked them. Yeah. So we have the same data. On the same date, we have 17. And this is what we picked yesterday. We'll take that one out for now. Okay, so we'll be using just the 17th data. Now we have from 10 a.m. to 5:45 p.m. So that's the day, 10 a.m. to 5. So we do it at maybe 5:50. Okay. You right click on your raw data, process data files, and go next. You select all the files you want to process. You select all of you check the boxes over there. Then you go to next. Here we have 1, 2, 3, 4, 5 options here. First, it says do not use tide corrections. Do not alter depth values. The values you are getting, the depth values you are getting, you are not going to do. You are just going to use it as it is. That's the first option. You are using it as it is. So the data, when it comes, it is going to give you your depth data untouched. That thing has been applied to it. And we have tide gauge or manual measurement as stored in raw data. With this one, when you go to site, you can also input the manual data, the manual level. You can input it before taking the data. So once you are done taking the data, it automatically stores the raw the manual tide, what you've taken already, the level. It stores it amongst the raw data that you've taken, so you'll not be doing any corrections over here. You just select that one, it takes the tide and then uses it to do the processing. And over here you have elevations from RTK receiver. And with this one, it ignores everything and then just takes the height that the GPS was broadcasting. Here you have ellipsoidal height and then mean sea level. So whichever one you want to use to do your processing, you use that. And this is the option we'll be using. Use tide correction. Over here we'll edit the correction file. So we'll add our level over here. We come to plus sign, add. The date is 17th. The time is 10 a.m. The level was 183.01. Okay. And then we add another one. That's the end. 17th. At 5:20, or is it 5:50? Okay. 5:50. Yeah, the same level. Okay, so that's going to be our reference level over here. Okay, so we save it. You save it in the folder you are working in. You have types over here. So you have manual type. Wait, 2020. And we save. Okay. So that's it over here. You can browse, search for it. That's it. Okay. Then we continue. With this one, it also uses the joint model and then the antenna offset you already have. So we'll be using the manual type to do the processing. Yes. These are default settings, you leave it. Now you filter your data. As I was saying yesterday, if you have a position like fixed status, you want it to stop taking the data or including those data inside the processing. Maybe once you were taking the data, it moved to float, and then it was still picking some data. You can take over here that whilst it was picking the data at float, it should include those images, those data. If you only want the face, you select the face for it to get it. Then you have the number of satellite counts. If the satellite count was less than this, it will remove that data from it and all that. We have that data over here. Any data below whatever you have inputted here or above what you have inputted here, it will also take those ones out. Then the elevation data and all that. But we don't apply anything over here. We just move. This is where all the work is. You edit the echogram. The spikes in there. You see the top here, the bars at the top here. It means that the echo sounder was receiving data. So in between here, it went off, and then it regained connection. So with those in between there, it's an assumed dead. You assume it, so you just make sure that this one connects to the next one. So it will assume it will just maintain the level over there. Exactly. It will maintain that level until it meets the next connection. The same way that's over here to the same way. So what we'll be doing is that we'll be taking out these spikes. So you right click and hold, then you drag along the spikes. You release and then you delete. Then it takes it. Current. Let me bring this here. Process. I'll bring this one here. Once you are moving along the echogram, you'll be seeing the location of the data. So if you bring it here, you can see everything clearly. Okay. But as you can see, that's the point. The orange circle on the right side.
The mouse.
Yeah. No, when I move the mouse, it goes. So the orange circle on the right side, it shows where the data was taken on the map.
I see.
Okay. So you just be monitoring the where the spikes occur, and then you see where the data is being taken. You can also know whether the data is right or the spikes do not make sense. As you can see, this one is in the water. The spikes over here from 3 just jump to 0 and count back. So you just interpolate this one. So you delete these ones. Then use the arrows on top of the window, the Echogram window. This one, it just skips to the last end. This one moves forward bit by bit. This one moves backwards bit by bit, and this one skips to the last end on the left. So we will be moving forward bit by bit while selecting the spice. Yeah. So over here you can see that there is no data over here. Over here too. So you'll be using your own discretion to be taking out this spice. Bye-bye. Okay. Oh, at this end here, it was stable for quite a while. So we have enough data over there, so we can just delete it. All of this, it was just immobile. It was standing there. No, it was taking the data, but it was standing there. So you don't need you don't need that data. So you take it from here, then you delete the whole thing. There. So you take it out of it. Because there's already some lines over there, meaning we've already taken those data already. Maybe we stood there whilst we were changing the trajectory, so once it was there, it was still recording the data. Okay, so when you are done, this is just for the first data. We move on to the second. You zoom in. With every line it goes, it has the part it draws. Yeah, but with this one, we did all in one. That's why you are seeing the data. So when you zoom in, you appreciate it a bit. You say you are deleting some of the relevant details, you can undo it or redo it. Okay, so you have the name prefix. All the raw data you have over here, each of them will now be converted to soundings. So what prefix are you going to give it? Just like you have raw 0001 over here, that one is also going to be the prefix you've given 0001. And so forth. The record interval over here, how do you want the data to be calculated? Here you have a calculate a sounding every 1 second. You have calculate a sounding for every received position fix. And the last one, you have calculate a position fix for every depth measurement. Every second it takes the data, you want it to calculate the sounding for it. The second one, you calculate the sounding for every receive. So every position data you receive, with a fixed solution, you ask it to create a sounding for you. But with this one, it says calculate a position fix for every depth measurement. You will be using the third one. With the first one, every second, your distance, the output sounder has been set to take the data 0.5 seconds. So you'll be skipping some data in between. And then when you are calculating the sounding for every received position fix, sometimes you can get the position data, but the output sounder wasn't taking the reading at the time. So with that one, you get position data without depth. So we use a calculate a fixed position for every depth measurement. So every time it picks a position data with depth attached, it should create the sounding for it. So that's what we'll be using. You okay that the raw data have been unchecked, and then now you have your soundings over here. So the sounding 1 generated from raw data 1, sounding 2 generated from raw data 2, and so forth. Okay. Once you are done with your soundings, you will create a matrix from it. Matrix, we are just creating a surface. Yeah. So generate matrix. On the folders over here, you right click on the matrix, you generate matrix, you select sounding data. We are using all the data we have. You okay. The boundary, you select the boundary. We are using boundary, that's I created a new boundary, that's the boundary. So the boundary covering the data we have, that's what you select. Okay, and we are using the sounding channel, elevation, high frequency. Okay, just a minute. Let's see the properties of the sounding data we have here. So right click on the sounding, go to manage soundings, and you have this sounding, you check edit sounding. We have eastings, northerns, elevation, tide, and then you have ellipsoidal height. When you double click each of them, you have from the sounding record, that's 1 point. 1 point on the sounding record. We have sounding 1, date, time, eastings of that point, northerns of that point. Additional information, speed at which the data was taken, the heading, ellipsoidal height, autometric height here is 0, mean sea level, the same. And then the tide correction we have. So where we are going to start, where we are going to use as a base to take the depth we have from it. That will be the tide correction. That's the water level. And then the raw depth that we are getting from the output sounder over here. So that's the data. Elevation height, tide, and then the ellipsoidal height. So once we are done, we'll be exporting all these files in CSV. And you can use it in AutoCAD. You can import it in AutoCAD, create your point clouds, and then use it to do your data. Or you can create the matrices. We export the matrix as last file, point clouds, then you use that to do you continue from there. Okay, so to export the soundings as it is, you export as files. Output folder, it goes to export. you merge all the selected soundings into one. If not, it's going to create it individually. So you select the soundings you want to export. Select all, okay. Now the exported fields will be exporting the corrected depth, the elevation. When I say you have high and then low, you always remember that it's a single frequency echo sounder and it's just the high frequency, not the low. Yeah, so you select here, we have corrected depth high, the elevation too high, and then the ellipsoidal height high. So you know the difference between the two.
With eastings and you have
The eastings here, northerns here. Yeah. If you want, you can also add the longitude and latitude if it is important to you. And you have time, you have dates, you have job, you have on also the what's necessary for you. You just include it. Let's see, object name. Okay. So field separator, you have comma, space, tab. So we'll be using CSV comma. Include header containing field names. Then you have your projection in meters. When you are done, okay, data has been exported successfully. So that's it. It opens the folder for you. That's the file. So here we have our object name from sounding 1. We have the eastings, the northerns, the ellipsoidal height, the corrected depth. That's what you are getting from the echo sounder. And then the elevation. So basically the elevation over here is just getting the tide minus the corrected depth to get the elevation. So maybe you can even put in the tide over here.
William.
Okay, we have tide here. Okay. Yeah, so you have the ellipsoidal height over here, the tide. So the tide minus the depth will give you the elevation. Okay, so that's the CSV for your data. And then we move on to create the surface. Okay, now you right click on matrices, you generate matrix. You select the sounding data you want included in your matrix, the boundary to bound the matrix, then the sounding channel using elevation, high frequency. The spacing of the matrix we leave it at default 1 meter. Browse, output, file. You also name your matrix. So over here it says, here is stage 5, right? The right side, stage 6. Okay. Okay, over here it has created the matrix, but you are seeing it in text form. I've taken the soundings out. You uncheck the soundings here, it takes it out. Now this is the matrix. It has created it in text form, so you are not really appreciating the text over here. So you come to matrices, right click, go to display options. Over here it says display matrix as colors, raster. So you select that one. We'll leave the values for now. Then we'll create the colors for it. Now you're asking it to create the matrix as raster color, but if you are not giving it any color, to just do this for you. So you have to give it the color to show the depth and each color that goes with it. So right click display options, we add colors over here. On this triple dots over here, you select, you add color. Okay, you close it. In this color, now we add auto. We generate it automatically. You use all the colors. What is the minimum depth? Now the minimum depth you are supposed to get is, I think it was a 10-meter range. So if it is from 183.09 and then the 10-meter range, you going down. So the minimum is going to be 173.019. Then the maximum is going to be the water level, 183.019 at an interval of 0.5 meters. If not, you can also use this to check your settings. So that's it. So you can also right click on the matrix you've created. This says matrix. You right click on it. You come to matrix properties. Inside here you have minimum and then maximum. So you can check it here and then you input it over there. So now that's the data. So as you can see, it has bounded it to the boundary warehouse. So even though you are not getting close to the boundary, the last data it places just inflates it and matches it with the boundary. So you have an option to export matrix over here. That's the matrix. The output format is a last point cloud. So you browse it. So we have add info, IPAC, last, PTS, XYZ point. So those are the formats you can export your data. So we export the last file for now, the last of XYZ. It also comes back into the export folder. So you name it page 6. So we export as XYZ and then last. So you can also create contours over here. So I think it is the contour that you can export as EXF. So you generate the contours. They say with this one you don't right click on the folder, you right click on the file. Generate contours. So that's it, the DXF file. or an SG sheet file. Those are the only two options we have here. So that one too, it takes you to maps. It helps this. Okay, so with the contours, we have used the following levels. We check the count to automatic. We input the minimum value as 173.019. Maximum value 18.01. Then an interval of 0.5. Okay, once you are done with this, you get the levels for it, minimum, the maximum value, and then the interval. You okay it. The contour smoothing, we leave it depending on the level you want it, however you want it to smoothen the curves. We leave it at level 5 and we see how it is. Okay. We use level 5. Okay, so now let's take out the text, the matrices in text. So display matrix as text, we just take it out. Okay, alright. So that's the contours. So
that's
yeah, that's the over here. It says 176. Just go back, generate the properties again. Is it the interval or okay? Okay. So we have our files here. We have our last files here. We have the sounding file here. And then we have the DXF and the maps. DXF right here. Okay. So that's for the surface. Now we'll try and then estimate the volume.
then
Yeah. So we have the tools, volume calculation, and matrix volumes. The matrix volumes over here, we are the sounding. We have sounding over here, so we'll be using the stasis matrix with the high frequency elevation, and then the reference is the water level. So we use a fixed level. So we use a fixed level. That's the 183.019. At the boundary, we are still using the same boundary. Okay, so you select the boundary, we come and check that everything is okay. The distance has gone back to 0, so just type it in again. 0. once you are done, you calculate. So that's the volume. Now above reference, below reference, the water level, below the water level, that's the volume you are getting. 724,362 cubic meters. So you can generate a report for it too. Yeah. The saved file as PDF. It goes into the reports folder. No. Okay, saves. Then save. 8, 4, 5, 20. Yeah. So you can see it in 3D over here. We have this matrix. Open in terrain viewer. Yeah. Reverse values. So that's it. So without the water, that's the overburden. So that's the term on this. I forgot you. Yeah, where's my over at the top here? Inverse value. Inverse, yeah. We just test it outside. Okay, so that's the report on the volume estimation. You have the name of projects, the dates, horizontal unit, vertical unit, projection, the matrix we use, the matrix type, the phase level we use as reference, the cell size, average level difference. Now overlap areas, none of the data crossed the water surface. They were all below the water surface. We have here the total area is this, and the total area that we covered is 100%. So below reference, that's it. None was above the reference. That's the total volume.
Thank you, Gideon, for yet another insightful video on how to process hydrographic survey data. Like and subscribe for more. See you in the next video. It's bye-bye for now.